Here we are going to see the constellation diagram of ASK. We know a constellation diagram is a representation of signal modulated by any digital modulation scheme. This digital modulation scheme can be anything such as ASK, PSK, phase shift keying, or quadrature amplitude modulation. Here we are going to see for ASK. We know our signal S of t, ASK signal as e cos 2 pi fct, and this was for bit 1, and we were not getting any amplitude level for bit 0, so that was 0. If we calculate the normalized power of this, then it would be simply the amplitude square by 2, and for this, since we are not having any level, then this is 0. Now energy is given as power into time, and we are calculating everything for 1 bit time period, then this is TB. We are analyzing for 1 bit time period. Now for bit 1, energy is given as our normalized power is a square by 2 into TB, and on solving this and calculating the value of A, we will get root EB by TB. This can be further written as root EB dot 2 by TB. Now we will put this in main equation. As we are calculating for bit 1, we will put in this main equation. Then we will get S of t as root EB 2 by TB. This is for A, and this is multiplied by cos 2 pi fct. Before proceeding further, we should analyze this quantity. Let us calculate the energy of this. For 1 bit time period, energy is simply the signal square. So here inside the rectangular box we have this, so square of this 2 by TB cos 2 pi fct square dt. And when we solve this quantity, we will get an constant, and this constant in mathematics it is called basis function. Here, and it is represented as phi of t. The English term meaning of basis is foundation. So this forms a foundation here, as on multiplying with this basis function we will get a unique signal, right? So as we have calculated for bit 1, I will write here for bit 1 we got S of t as root EB, and this was a constant term represented as phi of t. And for bit 0, we were not having any level, its power was 0, so anything with 0 is 0, hence for bit 0 it is 0 to phi of t. As we are representing each signal uniquely, hence I am multiplying with this basis function. We will plot the constellation diagram now. This is our phi of t. Here this is 0 dot phi of t, and this is root EB dot phi of t. This is for bit 0, this is for bit 1. This is called symbol as it represents something. This 0 is representation for bit 0, and this root EB is representation for bit 1, and this is our distance t. Now one thing to analyze, if d is increased, then probability of error gets decreased. Why so? As we can see, if their distance increase, then the bit 0 and bit 1 will be very far. Hence, they will not intermixed, and therefore our probability of error gets decreased.